In this case, we're told that we have f of negative 8 equals 0, and we're given this cubic polynomial. Now, what we're being told is that there is a root when x is equal to negative 8. Because we have a root at negative 8, we can figure out the fully factored form of this cubic polynomial. Very similar to a problem where I was given a factor. The factor that this came from was x plus 8. So because I know one factor, I can use synthetic division to factor this further. Now this original polynomial, I would have tried to factor by grouping because there's 4 terms, but it won't group and be able to have a common binomial factor. So we've got to go through the process here of synthetic division. Now, when we're given this negative 8 is the number that we would have put in the box for synthetic division because it came from an x plus 8 factor. They didn't tell us that. They just gave us the negative 8. So when we're given just the value, we just write x equals negative 8 in our little half box for synthetic division. And if you want to just reassure yourself, you write up top, hey, the factor was x plus 8, and that was equal to 0. And then we subtracted 8 from both sides to get that negative 8 value. But anyway, if you're just given the negative 8, just jump in there and start doing synthetic division with that value without changing the sign. So the biggest mistake people do is they go ahead and change that sign. Leave it alone, and then bring your coefficients down from the polynomial above. So we have 1, 12, 35, and 24 are our coefficients. And then we run through synthetic division, give yourself a little math bar. We bring down the 1, and we multiply. 1 times the negative 8 to get negative 8. And then we add, get 4. Repeat the process, times by negative 8. We get negative 32. We add, we get positive 3. We multiply that by our negative 8 and get negative 24. Now, this was supposed to be an opposite so that my remainder is 0. If my remainder wasn't 0, I had made a mistake somewhere because I was told that f of negative 8 is 0. So that's using the remainder theorem to know that the result here, that 0, is what f of that number is. That's the remainder theorem we've worked on before also. So what we're doing now, what we know is that there's a linear factor of x plus 8, and we just got a quadratic set of coefficients. Now that quadratic is because we had a cubic, we divided by a x to the 1, and that's going to give us a x squared result. So I put an x squared here, an x to the 1, and an x to the none. You put plus signs between because they were positive coefficients. And so my factors so far are x plus 8, and then x squared plus 4x plus 3. Now, this f of x just got factored to be that. So I'm going to write f of x equals. So I just took that cubic and factored it one layer, divided out a linear piece. Now, sometimes we get lucky and what's left is factorable. And in this case, we're going to try the magic x. Sometimes we'll have to use quadratic formula. That's coming. So here we have 3 on top, 4 on the bottom. In this case, we get lucky and it does factor. 3 and 1 are our magic numbers. And so we could do grouping, but because there's a 1 leading coefficient, we actually get to skip the grouping part. And so we just get to jump straight to our factors of x plus 3 and x plus 1. Don't make the mistake that many of my students have made where we just say that it's the opposite or it's the same values when it is not the same values. 3 and 1 are not the answers. This is supposed to be set equal to 0 to find all of the roots, the x-intercepts. So you set each one x plus 8 equal to 0 and solve, and you get x equals negative 8. You set x plus 1 or 3 equal to 0 and get x equals negative 3. And finally, x plus 1 equal to 0, and you get x equals negative 1. Try to do the due diligence of actually setting each term equal to 0 so that way you have less mistakes, making sure that you're actually getting the opposite sign to know what the zeros are. And again, the zeros are where this graph touches the x-axis, and we're going to eventually learn to sketch it to know that we have negative 8, negative 3, and negative 1, and we're going to use the fact that it's a positive a value odd degree function, so it's going to behave like a line in its ends. So where this is all going is we're going to graph a rough sketch using the x-intercepts and end behavior of this function. So that polynomial function looks something like that, and we get them even better details with getting a point or two.